In this class, we will start with the new module 4. So this will be the syllabus for the module 4. See, the module 4 is about measurement system and basic concepts of measurement methods. The other part is transducers, then intermediate modifying and terminating devices. So first we'll go into this measurement system and basic concept of measurement methods. So first we'll going to have this definition about measurement, then significance of measurement, then generalized measurement system, then about the definitions, some definitions or characteristics of the measuring instruments. So nearly 25 definitions are there in this, like accuracy, precision, calibration, threshold, sensitivity, hysteresis, repeatability, linearity, loading effect. Like this, around 25 definitions are there that we'll discuss. Then errors in measurement, then classification of errors. Till this one portion of this module 4, it will be there for the 7th question in the VTA question paper, right? This is module 4. So we'll begin with this module 4 now. First topic will be the definition of measurement system, right? So before going to that definition of measurement system or definition of measurement, right? See, Lord Kelvin has defined about the measurement. So when a person can measure what he is speaking about and express it in numbers, that means the person knows something about it. That is what the measurement is about, right? Right? So that is about the measurement. So when you can express what you are speaking about and express it in numbers, then you know something about it. Without expressing in a quantitative terms, if you simply say that the length is too long, the weight is too heavy or too less, it does not make any sense. They need to be quantified. It should be expressed in some sort of numbers for it. Then only the measurement will be the good thing what you can able to express. So that is what the Kelvin has stated it. Right? You have to express it in quantitative terms, in terms of some numbers. Then only you know something about that particular parameter. That is the meaning, right? So coming to the definition of measurement. So as all of you know that one measurement in general term, it is the determination of something which exists in some amount. Measurement is about the determination, finding out anything which exists in some amount. How much of amount that will exist, that is about the measurement is about in general meaning. But coming to the definition of it, see, measurement, it is considered to be as a process or it is a act of obtaining the quantitative comparison, right? It is a quantitative comparison between a predetermined standard and the unknown magnitude. As you all know that one, measurement is the process or an act of comparing. Which type of comparison? Quantitative comparison between the predetermined standards and the unknown quantity or unknown magnitude. That is what the definition of measurement is about, right? If you take the example, if you have to measure a line, you're going to measure the line with respect to some standard. Say for example, by placing the ruler or a scale, you compare the length of that line with that of the scale or the ruler. Then you're going to define it in terms of whether the line which you are measuring, it is 10 centimeter, 15 centimeter, 20 centimeter. You're comparing the unknown quantity, the line, with respect to that scale, which is a standard. That is what the measurement is about. And the standard here, standard is, it is something which is set up or established by a higher authority as a rule for measuring the quantities. That is called standard, right? It is a value of something which is set up by the or established by an higher authority as a rule. Rule in the sense it should be followed everywhere. So 1 centimeter is equal to 10 millimeter. So wherever you go, whichever the organization, if you go, that standard value is, it is going to be, you're going to follow the same thing. Or if you take the length, the unit of length, it is going to be in meters. That is a standard representation of the length. If you take the mass, it will be kilogram. So those are the standards which is set by the higher authority as a rule. That rule need to be followed. So that standard and unknown quantity, if you compare, you will go to get the result. And that result is about what? The measurement about. You can observe here in this measurement process. See here, this is the process of comparison, or you can call it as a measurement. See, unknown quantity, unknown magnitude, comparing with the standard. Then you'll come across the result. So which is nothing but the value of that particular physical variable. That is what the measurement process is about. You can observe in this image, this instrument here is shown. It is the pitch gauge, screw pitch gauge. This is a standard. Pitch gauge is a measuring instrument, right? This pitch gauge is having number of scales like this or blade like this, each one having the tooth profile with the numbers. You can observe over here, right? So this is a standard, and this is the component, a unknown magnitude, a screw. For this, if you want to measure the pitch of this, you'll compare this unknown quantity or unknown magnitude with that of the standard. So standard is screw pitch gauge. So whichever the profile of the thread in the blade matches with this profile of the screw, which is a component, then that will be the number. So that is what this measurement process is about. Unknown magnitude is this, standard is this. So you're doing the comparison, a process or act of comparing between these two, and you're going to get a result. That is what the measurement is about. The next topic, it is about requirements of measuring system. Why actually the measuring system is required? Actually, the two main requirements in order to do the act of measurement, for that two requirements are there, right? Those two requirements of this measurement or measuring system is, the first one, the standard used for comparison must be accurately defined. So whatever the standard it is being used, in this example, this is the standard. It should be accurately, it should be defined, that value, right? It should be followed and commonly accepted. Suppose if you take the example, a length cannot be simply set as too long, but it must be set, it is comparatively longer than some standard, right? You can observe the examples over here, right? You can't express simply the object as too long, too short, or bigger size or smaller size. You have to express in terms of numbers. In order to express it, you have to compare with some known standard. In this example, this ruler is the standard because it is acceptable. It is commonly accepted. 1 centimeter is equal to 10 millimeter. This is the standard. It is followed, right? And it going to accurately defines it. It is being accepted. So this is the one of the requirement for the measuring to happen. The standard which is using, it must be commonly accepted, and the value should be accurately defined. That is the one requirement. Another requirement is the procedure for the comparison, right? For the measurement, and the operator used for the comparison must be provable. What comparison you are doing for the measurement and the operators, that should be provable. So these are the two requirements of measuring systems. So next topic is significance of measurement system. The importance of the measuring system. Why it is important? Why the system measurement system should be followed? So basically, it defines in the 4 keywords, and those keywords here I have underlined. You can observe here over here the 4 points, right? With respect to these keywords, it is being defined the significance, the importance of the measurement system. See the first one, measurement provides a fundamental basis for R&D, research and development. In order to develop the product or any of the component, it will be the final stage of the design procedures, which involve lot of measurement to be happen. Lot of measurement means measuring the various quantities pertaining to different performance, different operations of the device which is being involved for the development of the product. Without measurement, it is not possible for the research to happen, right? The development of the new product, the development of the new component, the optimization, or if you want to go with the new products, the research, without measurement, it is not possible. So this is a main significance of the measurement system. It is the fundamental basis for R&D, research and development. The second significance of this measurement system is it is a fundamental element of any control process. See, any process, if you want to control it, say for example, a manufacturing process, if you want to control it, you have to measure it. Without measuring the process, without measuring the output of it for a particular manufacturing process, how it is performing, you need to control it. In order to control it, you have to do the measurement, and the measurement is the another important fundamental the element in the control process. Without measurement, it is not at all possible to control any physical parameters. So that is the another significance of measurement system. It is a fundamental element of any control process, so that you can able to define the performance. You can able to control the performance of any of the physical quantities. The third one is many operations require measurement of proper performance. Many of the operations require measurement for proper performance. When performance coming to picture, performance, how better the performance of the product or the component after manufactured during the assembly line, that require measurement. If you take the physical parameters like temperature, pressure, variations, how it is performing with respect to those, it is monitored by using the measurement system only, measuring system only. Without measuring, you can't check or you can't say it is performing well enough to the requirement level. With the measurement only, you can able to say it is performing better. Without measurement, you can't judge it whether the performance is having to the required level or not. If you simply say performance is good, better, best, it won't add the value. How much of performance it can able to produce, how much of the level at which it is performing, that it should be having, the measurement is required. Each individual product require enhancement in the performance. Not enhancement in the performance compared to the previous performance, you need to have that data. So the data is nothing but that measurement. Without that, it is not possible. There is another significance of measurement system. The fourth one is measurement is also a bias of commerce. See, commerce means the buying or selling the goods, right? It is a bias of commerce because the cost of the product established based on the amount of raw material involved, amount of machine hour or the man hour, all these constraints. Without having those knowledge of it, we can't judge the cost of the products, right? So those are the some of the significance or importance of the measurement system. It is required for R&D, it is required for controlling any of the process, it is required to measure the performance properly, and also it is for the commerce, for trading the goods. The knowledge of that measurement is very much essential. So this is the significances. So next topic is fundamental methods of measurement. So in order to do the measurement, we discuss the significance, the four major significance or importance of the measurement, but the methods of doing this measurement. The methods, there are two common methods which is involved to do the measurement. One is a direct comparison, another one is indirect comparison. That is a direct measurement, indirect measurement. See, for direct measurement, it is with respect to the standard, primary standard or the secondary standard. It will be involved for doing the direct comparison. First, we'll discuss about the direct comparison. The direct comparison is one of the method of doing the measurement. As the name implies, it directly compare the unknown magnitude, unknown quantity with that of the standard. And the result will be expressed in terms of quantitative number. That is direct comparison. It compares directly. Suppose if you take the same example, the scale with that of the object, it comparing. If you see the example, if you want to measure this object, direct comparison, you're comparing the length of this object with respect to the standard, primary or secondary standard. So whatever the length it will be there, after comparing, it will be expressed in some quantity number. It can be millimeter, centimeter, meter, right? Any desired unit. But this is what the direct comparison, comparing with the primary or secondary standards directly. That's why it is called direct comparison. See, this type of comparison, it is easy as well as it is very quick to get the result. It is to get the quantitative number. Usually for the length, mass or other physical parameters, they will going to measure in terms of this method, direct comparison. You can observe here in this example, this is the measuring tube which is having the markings on it. So this markings will act as a standard, and the amount of fluid or the liquid which presents here, that will become the unknown quantity. So comparing this unknown with the marking, that is the standard, and express in terms of some number. 40 ml is there, 50 ml is there, 60 ml is there. That result, it is what the direct comparison. Even though this direct comparison is quick and easy to be used to get the result, but it is also having some drawbacks. The main drawback of this type of direct comparison is that it is not always accurate. It is not always reliable. You can't rely on this type of result which comes from the direct comparison method. And also it is not always accurate. Suppose if you take this example here, some person may say it is 51 millimeter, some may say it is 52, some may say 53. It is not accurate. It is not reliable. There will be some variations will be there. As you know that one, why that variation it will be there? It is because of parallax effect, right? Which we discussed earlier. Parallax effect. It is always depends on the human operator. The angle of view a little bit changes. The angle of view it will go to having the variation. Not only that, the person, the the way in which he hold the component with respect to the standard each time maybe a little bit of variations will be there. Because of some of these conditions, it is not always accurate and it is not reliable. One of the major or main drawback of this, because the major another reason for this it is not accurate because it depends on the human senses, because the human will take the reading, the person will take the reading, the operator will take the reading, right? It always depends on the human senses, right? Because the person or the operator when he is taking the reading, he has to compare it side by side, the unknown quantity with respect to standard, then he had to express that value. That means he has to judge how much the quantity is depending on his senses, his experiences, right? And also another reason, another drawback is this type of direct comparison is not always possible. It is not always practically, it is not feasible also. Not possible, practically it is not feasible also, right? These type of direct measurements. Suppose if you want to measure the temperature, measurement of the weight, those direct comparison, direct measurement won't happen. Some sort of magnification, some sort of conversions is required, right? So these are some of the drawbacks of the direct method of doing the measurement. So if you take the example of the temperature here, one person may feel that the present temperature is cold, whereas other person he may feel that the present temperature is little bit hot, because it entirely depends on the human senses. It can't be judged directly, right? The temperature. These temperature, weight, it depends on the human factors, and it is not preferred or not a very accurate type of measurement for these type of parameters, the temperature, the weight, those things, right? Coming to the second method, indirect comparison. You can observe here, most of the measurement system uses indirect method of measurement. Most of the measurement system uses indirect method of measurement because of these drawbacks, because it depends on the human senses. The human factor will coming to picture. It is not feasible, it is not accurate, and sometimes it is not practically possible. Because of this, indirect way of doing the measurement will be preferred more. in the measurement system. As compared to the previous one, in this indirect comparison, it consists of chain of devices. Chain of devices. More than one element involved in the measurement system, which will facilitate the operator to obtain the accurate result. As compared to the direct method of doing the measurement, in this method, indirect comparison, it consists of a chain of devices, different elements involved, which will facilitate the operator to get the accurate result, accurate value. See, these chain of devices, it will transform the signal into more convenient form. It will be recorded, then it will be displayed. Finally, the operator can able to read it or view it, right? You can observe here, this is the board-on tube pressure gauge. This is the device which is used to measure the pressure. It also comes under this way of doing the measurement, right? There will be signal which will be sensed. It will be enhanced, it will be magnified to the required level, then it will be displayed, so that it will be easy for the operator to get the reading. A chain of devices or chain of elements involved in it. So this is what indirect comparison, right? That is, it uses a transducing element which convert the basic form of input to analogous form, which it then process it and finally it going to functions it for the input which is being given to it. If you take this example, board on tube pressure gauge, it does not require the human senses, right, to detect the quantity like the pressure or the force, or if you take the strain, it does not require the human senses to take the reading, right? It directly is going to mention over on the dial. After magnifying, after transducing all these things, it is going to display, right? So a system is required which can detect or sense, which can convert and finally presents the output in the form of displacement, some pointer moving on a scale, right? That is what this board on tube pressure gauge. That is what the indirect comparison about. It consists of a chain of devices. It does not depend on directly on the human factor. Here one example of this indirect measurement. Suppose if you want to measure this height of the tree with respect to this, a person that is 5 feet tall that cast a shadow of 4 feet is standing next to a tree that cast a shadow of 10 feet. How tall is the tree, right? There is an indirect way of doing the measurement, right? Direct if not possible, go for the indirect way. If this is having the yardstick is having this much of the shadow, then for this how much it will be. Those are indirect way of doing the comparison or measurement. See, one example of this indirect measurement or indirect comparison, what you are seeing on the screen, it is called strain gauge. This is also a practical experiment you will conduct in the M lab. This is also, it will be there, strain gauge, calibration of strain gauge. There is the name of the experiment which you will going to perform in the M lab individually. Strain gauge. What you are seeing, see the cursor. So this is what the strain gauge it look like, right? It is like a thin paper, right, which is flexible enough. So these what you are seeing, the black lines, these are the grid. Whichever the component which you wish to measure the strain, it will be stick on to it. Suppose in this case, this is the load cell, what you're seeing in the animation. So if you wish to measure the strain of it, the deformation of it, this will be stick on to the different places. So whenever the load is applied, it will deform. Whenever it get deformed, these strain gauge, what you're looking here, see here, you can observe here also, this is the cantilever beam. For this cantilever beam, when the load is applied, this cantilever beam will go to deform, and the amount of strain possessed by this cantilever beam can be measured from the strain gauge. This type of strain gauge is stick here as well as at the bottom. See here, the top side strain gauge will sense it in terms of tension. You can observe here, right? Because it is deforming, it will go to deform like this tension. The bottom one will going to have the compression. So this is the Wheatstone bridge, and on this digital strain indicator is going to get the reading. Once you apply a load here, this cantilever beam will deform. With the help of these strain gauges, it will sense that pressure or the force. Then it will convert that into strain. Because of these resistances, these strain gauge, you can observe here, the wire connections will be made to these Wheatstone bridge. Because of the variation in the resistances, you're going to get the value on the digital indicator, which will indicate the amount of strain sensed by this particular cantilever beam. So this is what the strain gauge, a measurement of strain. So this is not a direct comparison or direct way of doing the measurement. It is indirect comparison or indirect measurement. You're not just comparing with some standard. Here, the force what you're going to apply will be in terms of weight, standard weight. For that weight applied, how much is the strain experienced by this particular cantilever beam, which will be sensed. It is an indirect way of doing the measurement. Most of the measurement system follow this indirect way because it does not have the drawback of the direct way of doing the measurement. Right? So this will be there in the Trivium lab. We will going to perform this experiment. You'll get to know about this strain gauge. So next slide is about comparison between these two. So direct comparison, indirect comparison. The differences. See, direct comparison, the unknown quantity is measured comparing directly with primary or secondary standard. Direct comparison with primary or secondary standard. If you see over here, indirect comparison, the unknown magnitude is measured by comparing with standard indirectly through the use of calibrated system. There will be some calibrated system which consists of chain of devices, elements. By comparing with that standards, you can able to do the measurement. Whereas here, just a standard is enough to do the measurement, but there will be calibrated system is also involved in direct comparison. See, under direct comparison, human senses are very much necessary for the measurement. So this is one of the drawback of this direct comparison. It depends on human senses. Human factor is very much important here. Whereas if you see the indirect way of doing the measurement, it consists of chain of devices which form a measuring system. That is, it does not rely on human senses. This indirect comparison does not rely completely on the human senses. It relies on the chain of elements, chain of devices. That we will discuss in the coming slides. What is this chain of devices means? See here, the direct comparison, the third one, result obtained from direct comparison are not that dependable. Under this indirect comparison, this consists of a detector element to detect, a transducer to transducer, and a unit to indicate or record the process signal. See, so many elements it is involved in this. Whereas here, there is no so many elements. There is no chain of devices. So here it consists of chain of devices. Stage by stage, it will perform their own operation. Then it will produce the result. See here, direct comparison, not always accurate. It is not reliable. There is some variation because human factors are involved in direct comparison. Whereas if you take indirect comparison, it rely on the different elements which involved in this for the measurement to happen. See some examples here have been mentioned under direct comparison. These are the examples. If you take the stainless steel scale or the ruler, direct way of doing the measurement. Vernier caliper, micrometer, all those are the examples of direct comparison. If you take here the example of indirect comparison, the strain gauge. What here I explained that strain gauge, right? Indirect way of measuring the amount of force applied in terms of strain for this element, right? By using this Wheatstone bridge. So this is the strain gauge. And suppose this you see over here, if this is the element, if this is the bar for which you have to measure the strain, they will stick the strain gauge like this. I hope all of you can able to see it here, right? It is being pasted onto it, right? These are the connections. It will sense the deformation of this for the amount of load applied on the one end of it. So finally, it is going to give the value like this on the digital strain indicator device. It provides the value on it. So this is what the strain gauge example for indirect comparison. Understood? We move on to the next topic, generalized measurement system. As the name represent, generalized. This is important. Most of the time, this question will be asked in the question papers, right? Generalized measurement system. Irrespective of any sort of measurement system, it consists of these three stages or these three elements. We can consider this as chain of elements or chain of devices. A measurement is considered to be as a measurement system when it added some of the elements, and those elements here it consists of the stages, right? You can observe here in this image there will be a detector transducer stage. The second stage is intermediate modifying stage, and the last stage or the third stage is a terminating stage, or it is about a readout stage or recording stage. These are the three stages involved generally in the measurement system. See here, the first stage, detector transducer stage. As the name represents, it is for detection. Detection in the sense, it will detect the input signals, right? Whatever the physical parameter which you are supposed to measure in the particular measurement system, the first thing what it going to receive the signal is the first stage, detector transducer stage. It is considered to be as like a sensor which will sense the input signals. See, these transducer stage, you can observe here, input signal, it is been sensing by this detector stage. It will detect the input signal. That is, it should sense the input signal. You can observe here, there is a calibration signal is there that represent that even though it is a detector, like a sensor, which senses the input signal, but it should be insensitive to other sort of any noises. It should sense the input signal. It should sense all the signal which is having the positiveness to have to convert into value. At the same time, it should be at the position that it should not detect the any of the noises, insensitive to those things. That is what the calibration signal is about here. That's why it is being mentioned. Only the signal which is having that strength, only those things need to be senses by this particular stage, right? See, for this, auxiliary power source is required. It is optional. See here, if you take the example here, board on tube pressure gauge, it will sense the input signal. What is the input signal for this pressure gauge, board on tube pressure gauge? The input signal is obviously the pressure, right? It should sense only the incoming pressure of the air or the fluids. At the same time, it should be insensitive to the other noises. But unfortunately, it is very rare to find a detecting device which is completely sensitive or completely selective. Some sort of noise, it will going to sense it. Actually, it should not sense those sort of the noises, but it is not possible to have that sort of device which is insensitive to the noises. Some level it will detect, right? That is what the first stage is about. Detector stage. It sends the input signal and it should be insensitive to the other sort of signals like noise. Coming to the second stage here, intermediate modifying stage. As the name represent, modifying. It will modify. Intermediate, in between. Intermediate means in between. Between the first and the third stage, here it will exist. It will modify the signals. That's what is called intermediate modifying stage. See here, the input for this second stage is the transduced signal. So whatever the signal the first stage will send, that will be the input for the second stage. So usually it will be analogous. It will be of one form, analogous input. The purpose of this second stage, intermediate modifying stage, is for signal conditioning. Whatever the signal it is receiving from the first stage, it need to be conditioned. Like the hair conditioner, it will be there. Similar to it, it will be applied later once it is been modified, right? Similar to this, in order to enhance the strength of the signal, this is required. Intermediate modifying stage. The input for this is will be the output of the first stage. It will make the signal to that extent, to that standard, which will be acceptable by the third stage. That is, the output of the second stage will be the input for the third stage. That is a readout stage, right? The important function of this second stage is to increase either the power or the amplitude of the signal. The importance of this second stage is to increase, to enhance. Modifying means to enhance to the betterment, to enhance the amplitude, or to enhance the power of the signal which is receiving from the first stage. See, the first stage, it does not make any changes to the signal what it is been receiving. As it is, it will send it once it is been sensed. That signal, if it is weak, it need to be strengthened, and that function will be performed by the second stage. That's what is called signal conditioning stage, or it is also called intermediate modifying stage. It will modify the signal to the level which is required by the final stage, right? The next stage here, what you can see over here, it is the terminating or readout stage. These signals, what the intermediate modifying stage will send, that will be recorded or it will be indicated on the dial with a pointer, right? So that is what this generalized measurement system is all about. There will be a sensor like a detector which detect only the input signal, like calibration signal. Then it will send it to this second stage, intermediate modifying stage, where it going to enhance the signal or enhance the strength of the signal to the required level by the second stage by using the auxiliary power source. Then finally it will be recorded or indicated or it will be controlled. So this is what generally the three stages involved in the measurement system, measuring instrument. Irrespective of any other, it consists of these three stages: stage 1, stage 2, stage 3. With respect to this, I will explain this generalized measurement system in the coming slide, right? See here, this is what the board on tube pressure gauge. What you are observing here in this is the device. The line diagram of this board on tube pressure gauge, which is used to measure the pressure. That is this diagram, right? You can observe here board on tube pressure gauge as generalized measurement system. How this board on tube pressure gauge is considered as a generalized measurement system. See here, pressure input. At this point, it acts as the detector stage. Once the pressure is being, this is a signal, right? Pressure. Once it is being supplied into it, it will, this tube will going to sense it. That is, it is going to take the signal, sense the input signal. See here, board on tube. This particular tube, what you are seeing, this is a flexible tube. It tend to move in the circular direction. Whenever the pressure of air, say for example, air is being supplied, this flexible tube will tend to rotate, will tend to move. See, this acts as detector transducer stage. You can observe here the previous one, detector transducer stage, the first stage, this one, right? Then again, this board on tube pressure gauge, it consists of the pinion as well as the gearing mechanism. The gear pinion will be here. You can observe, right? This is the tube. This tube, it connected with a link lever. and for this lever with a gearing mechanism will be here. These gearing mechanism, what you can observe, it acts as intermediate modifying stage. You can observe here the second stage, intermediate modifying stage. This is the second one. The function of this is to amplify, to modify, to enhance the power, to enhance the amplitude of the coming signal. So that will be done by this gearing, the lever and the gearing. You can observe here one more element, the pointer as well as the scale, and these acts as the terminating stage. You can observe the pointer, terminating stage. Here indicator, it acts as the terminating or readout stage. So finally you're going to get the reading, pointer moving on a scale. So three stages represented with respect to this board-on tube pressure gauge. This is just one example. Multiple devices will going to have these type of three stages. That's why here generalized measurement system. So this table, what you are seeing over here, it is some basic elements of the measurement system. For different measuring instruments, that is mechanical one, that is hydraulic, optical, electrical instruments, all those things generally will have these three stages. You can see here the screen, the pointer, stage 1, sensor transducer stage. So this acts as the sensor, the first stage. The second one is signal conditioning. It acts as the conditioner, signal conditioning to the better level. The third is readout stage or recording stage, the pointer moving on a scale. Right? You can observe here the types and examples. Types and examples. If you come to the mechanical instruments, the sensor stage or the transducer stage, some examples is mentioned here with respect to mechanical measuring instruments. Here, contact spindle. Suppose if you take the example of a dial indicator, in that dial indicator, it will going to have a spindle or a plunger which sends the input signal, right? That is a mechanical one. Suppose if it is having the elastic devices, like here elastic devices means you can observe here, this is the elastic element, a board on tube for measuring the pressure, or if it is a proving ring to measure the force, all comes under mechanical element, and all these are comes under the first stage, sensor transducer stage. All acts as the sensor which sends the input signals. Similarly, the second stage, if it is a mechanical measuring instrument, the elements, see here, the gearing, crank, slides, connecting link, cams, all these considered to be as the signal conditioning elements for mechanical instruments. You can observe in this example also, here this gearing mechanism with the lever, it acts as the signal conditioner. It enhances the input signal which can be read on this scale. That's why here it is being mentioned mechanical. If we take the third stage, readout stage for mechanical measuring instruments, indicators. Indicator, that means you can observe here the pointer and the scale. Pointer moving on a scale, it is mechanical. If we take hydraulic, similarly, if it is hydraulic one, the sensor stage is the orifice, buoyant float, venturi, vane propeller. These acts as the first stage. Piping, valve, The chambers, these acts as the signal conditioning. Again, for hydraulic pneumatic one, the indicators, direct alphanumeric readout, those acts as the third stage. Likewise, optical, electrical, right? For different instruments, these are the general three stages. Now we can observe this, the same example, board on tube pressure gauge, right? This is the example which has been taken to explain this generalized measurement system. See here, the three stages. This is detector transducer stage, intermediate modifying stage, terminating stage. With respect to this as an example, board on tube pressure gauge, detector transducer stage. Which one is acts as a detector transducer stage? In this example, you can observe here, it has been mentioned. It is the board on tube. That is what it is mentioned here. Detector transducer stage. In this example, it is board on tube. Then the second stage, intermediate modifying stage. You can observe here, intermediate modifying stage. In this example, it is the mechanical link and the gears. That is what here it is mentioned. Mechanical link and gearing. The third stage is terminating stage. You can observe here, terminating stage, pointer and scale. That is what it is being mentioned. Three stages with respect to this board on tube pressure gauge. Says input signal is pressure. Then the displacement. Displacement means displacement of this particular board on tube. We can observe here this animation. P represent pressure. Once the input signal is being sent, see this particular the board on tube. It is being displaced because of the pressure is exerted into it. You can observe here, right? Board on tube, a flexible tube. You can observe in this animation. Because of this displacement of this tube, board on tube, what will happen to these link and these gear mechanism? It will be moving, right? Because of this, the pointer which is attached to it, it will be going to be moving. Finally, here you can observe, you can get the reading for the amount of input signal on the dial. It is a mechanical instrument. The example what it is being shown, it is a mechanical